So one of the things that makes the CRETE house highly resilient is the inherent structural integrity of concrete. For instance, concrete is a lot more resilient to fires, mold, water damage than other wooden houses. And one of the things that's great about the CRETE house is that, especially in the Midwest, we have a lot of tornadoes, so our house is highly resilient to tornadoes from F1 all the way up to F5.
Since very early in the process, we decided to make this house to be built out of concrete. The reason for that is because Hongji and my own experience with this material, and also because it's not very common to have, for sort of Decathlon, a concrete house. I think it happens only twice so far. This is going to be the third time that a team is offering a concrete house. So we wanted to, we believe concrete is sustainable and concrete is very resilient. And we know that it's not as common to have a single family residential home made out of concrete. Precast concrete in particular is very widely used in larger scale projects. It's going from infrastructure, bridges and highways down to big scale buildings, hospitals, warehouses, and student dorms and universities. So those kind of projects are typically the precast market. Residential project also, multifamily, this is fairly common, but single family residential is not. So we use this competition as an opportunity to offer an alternative to the most traditional material, which is wood, like frame construction. So we set this as a challenge, Hongji and I, at the very beginning, and then Ryan came on the way later on the process. Our challenge was to say, okay, let's propose concrete as an alternative, as I mentioned, to light gauge steel and light frame wood construction. So concrete is resilient because it's resistant to fire, to mold and moisture. It's resistant also to insects, and it's also resistant to extreme weather conditions. Because it's heavy, because it's strong, it can easily withstand tornado and hurricane conditions because of the structure of the material. We actually performed a test a few days ago in which we shoot a canyon to a precast sample, and we compared that with brick construction and wood construction. So this 2x4 was shot at over 100 miles per hour. It went through all the other structures, but it didn't even scratch the concrete. So that was kind of a way of demonstrating the resiliency against, in this case, against tornado debris flying on the air. So the only downside that concrete has, in my opinion, is the weight, because it's heavy. But also that even though it's for transportation purposes is a downside, but it's also a good thing for storms, because the weight of material makes the structure a lot more resistant. In this particular project, regarding the weight, what we set up as a challenge also was to find a way to minimize the weight of these sandwich panels. And maybe I need to explain briefly how this works. Typically, a precast panel is composed of 4 inches of concrete, traditional concrete, 3, 4, 5 inches of insulation, and another 3 inches of concrete on the outside. That's a typical sandwich precast panel is made out of. So for this particular project, we decided also since the very beginning using a ultra high performance concrete layer on the outside. So going from 3 inches to 1 or 1.25 inch or 1.25 inch on the exterior layer. That means we use a very specific material which is called ductile. Ductile is, as I said, an ultra high performance concrete that's manufactured by Lafarge, a French company, and it's a super resistant material. It's 6 times stronger to compression than a traditional concrete. So by using this outside layer, we were able to decrease the thickness of the overall wall by 25%, and also therefore by reducing the thickness we are reducing the weight of the material. So overall, this is the first time, by the way, that this is done, sandwich panels using ductile. So we're very happy to be the first house that is actually implementing this. So we have the support of these companies doing this for us. So then what we are proposing is what we call a ultra high performance envelope, because we have this thin layer of ductile on the outside. Using ductile also, we are able to have a lot more detail on the texture of the facade. As you can see later on the construction of the house, you will see that the exterior surface and texture of the envelope of the walls is very delicate, it's very intricate, has a lot of indentations and a pattern that is very strong. That also gives us some kind of dynamic aspect to the facade, because the sun is always moving around, so the house is never static. It's always, as the sun moves, basically the house is showing shadows that are changing all the time. So what we're saying is the house is a box, as you can see in the project, it's a simple structure, but has this dynamic aspect on the texture of the facade that makes it a lot less static. So by using this kind of new envelope, we are arguing that this is a way of decreasing the thickness, but it's also a way of decreasing the weight of the overall structure. So we think that this might be a good alternative in the future to create lighter and thinner panels without losing any type of resistance, in this case to extreme weather conditions.